So you will see that come up again and again, this idea of following conventions, right? And as opposed to having everything done in configuration settings and so on. So what we're going to do next, we've got this one controller here, but it really just brings up our boilerplate pages, right? We'll get more into how the different views and the shared views work later on. But I just want to get moving along with models, views, and controllers. So what I'm going to do is I'm going to build my medical office example, right? So I have doctors and patients. A doctor looks after many patients. A patient, obviously, in an emergency, you'll see any doctor that's available. But usually there's one sort of assigned primary care physician or family doctor, right? So it's a one-to-many relationship in the way I'm going to put these classes together, right? The online tutorial goes through a lot of the same information, but they only use a single entity, so it doesn't give you a chance to see the navigation properties between the parent and the child that we'll be covering. So to actually create a model class, it's a simple matter of right-clicking and saying add. I can say class, right? So maybe I'll start with doctor. So here's my public class doctor, right? Now, just to get into this idea of conventions and so on, every entity, like every table in a database, should have a unique identifier, a primary key, right? So there's a convention here for how I'm going to create a property inside this class that will correspond to this primary key concept. Essentially this, I can either use just the letters ID or the class name with ID at the end. So I could go Doctor ID or just plain ID. Usually I just stick with ID. There's no real confusion between classes because every class is its own, right? And it actually works better later on when you get into inheritance, right? So you might have a person class and later on, students and teachers and other classes that inherit, right? It's easier if everyone is just ID, then you don't get as much confusion, because if you say person ID, well then, everybody, anyway, it works better. To add properties, I'm not sure if everyone has had a chance to see some of the snippets that are built in Visual Studio. For example, if I just go prop, P-R-O-P, right, you can see I've got a choice of snippets that I can utilize. So, for example, prop full, if I select that one and just go tab, tab, then it creates the full breakout with a getter and setter, okay, of a public property, and there's a private internal variable to hold the value, right? That's how you probably wrote a lot of your properties in your C# course last term, am I correct? Okay, no? Okay, well, some people did. All right. But, there's a simplified version of the exact same thing, and that's just if I go prop. So if I just go P-R-O-P, tab, tab, right, then this is a simplified property. If you don't really need to do much programming in the getter or setter, then this is more succinct, and it actually compiles to the exact same code in the intermediate language anyway, right? So in the end, it amounts to the same thing. It will create an internal variable and then have the public getter and setter for the property. Okay, but it's not done. It's still there helping me because it's highlighted the data type. So I could just type whatever data type I want and change it. It happens to be that I want an int anyway, so I'll just press tab to go over to the name of the property. So I'm just going to give it the name ID, right? As you find pressing end, goes to the end of the line and enter. And now all the highlighting is gone. It's finished making that property. So that's it. I've made the primary key property for my actual doctor table already, right? Now, in my copy-paste code, you see I've got things like first name, middle name, last name, and so on. I could start with these kind of vanilla ones, but you'll notice in my copy-paste code I've got a second set that include data annotations. I know I showed data annotations to the people I was teaching over the summer. Has everybody seen a data annotation on a property? No? Okay. All right. Well, maybe I'll do it a little bit more one at a time. So I'll make another one here manually. So prop, tab, tab. This will be a string data type. I'll tab over, and I'll call it first name. I didn't hit my tab properly. Okay, first name. Okay, So I'll make a public property with a getter and a setter for the first name, right? Now, the only issue is, if I migrate this class right now to the database, it will actually generate a create table statement where this will be identified as an integer identity. Remember what identities do in SQL? Yes? No? Remember making an identity? It would automatically generate a new value, like an auto number field. Okay, so if the primary key was an integer identity, you could specify a seed and an increment, right? By default, it'd be 1 and 1. Yeah, I see more people nodding now. It's coming back. Those brain cells are remembering the the fun you had in that course. That's good. Okay, so that's what I get by default just by having an ID integer property, right? This name, okay, it's going to say, oh, okay, well, we have to make a corresponding database field. Problem is, right, strings can be null, so it would assume, well, obviously this field should be null. Well, what if I want to make it required, for example, right? Well, I could do that with an annotation as I build a model here. I could put the square brackets. If I type required, the system's going to yell at me. What are you talking about? I don't know what that means. Well, it's because I don't have a using at the top. There's a namespace where all these annotations live, right? Fortunately, Visual Studio is here to protect me from myself, right? Or save me from myself at the very least. So what I can do is I can hover over it and see the little light bulb flashing at me. Okay, if you're good with a mouse, I can click the little drop down arrow beside the light bulb and get suggestions. I'll zoom to the back of the room. Suggestions like, oh, add the using to your class. System.componentModel.dataAnnotations contains all these very useful annotations, okay, for data objects, right? By the way, if you hate working with the mouse, and you find that every time you go to, you're almost on top of the little light bulb and he moves somewhere else, because sometimes he does that, he moves over here and things like that. You can just click anywhere inside the underlined word, and the keyboard shortcut, this is one you're going to want to remember, is Control, hold Control down and hit period. That's often much faster and easier than struggling with the mouse. It gives you the same list of suggested solutions to the problem. So if I say, yes, please, add my data annotation. There we go. What it did up top, there it is, System Component Model Data Annotations. Okay? It was, the DLL was available to the project, but it didn't have a using in the class, so it didn't know to look up what a required attribute was. Now, when I migrate this to the database, my first name field will now be not null, because it's required, right? So that's good, because annotations help us with the database design. The other big issue I'm going to have with the database design based on my model is how much characters can you hold in a string? Anyone know the limit? You know what? I didn't even know the limit off the top of my head. It's so big, I never have to worry about it. So what does the database do? Well, when migrating this into a database create table statement, it uses the biggest thing that can hold the biggest possible string you can think of in SQL Server. Anyone remember what that would be? And varchar max, right? You can hold 10 copies of Encyclopedia Britannica just about inside of an n varchar max. Kind of a waste of space in the database for a simple string like a first name, right? So we can get around that by giving kind of a hint to the database when, as it's created by Entity Framework, by adding another annotation. So let's add another one. Oh, string length. See, now that I've added the namespace, I get IntelliSense on these as well. String length, and if I hit a bracket, then I get IntelliSense maximum length. So, I don't know, maybe 50 characters. I can't imagine a first name needing more than 50 characters. If I think I need 100, I can use 100. Whatever I think I need, right? And that is now good. So then, when it creates the database, it'll be an nvarchar 50, right? So it'll control, these annotations will dictate aspects about how this is created inside the database for the actual storage of the information. But that's not all. That's not all you get for these annotations. Sound like the Ginsu knife commercial. Oh, wait. We're also going to throw in help for the user interface, right? So instead of just saying the first name field is required, every one of these, notice that there's additional options, and you can specify by naming parameters. As soon as I type a couple letters, I get IntelliSense error message. Error message equals you cannot leave the first name blank. Right? Something like that, for example. I better zoom back out a little bit. Okay. Oh, I better get a round bracket in there. I'm going to get into trouble. And there we go. And back for the string length, I can do the same kind of thing. If I hit the comma, then I can add more attributes here. So I can get error message equals. I could be nice and friendly, you know. First name is too long. Right? Nice friendly message to the end user. Or I could actually say that you're only allowed 50 characters, but you know that's not near as much fun, right? Let them guess. I'll take one off and see if it fits now. Ah, oh, no, right? Okay. So this is what we get with annotations. We can do things, right, that will affect both the database in the back and the user interface in the front. Because these error messages will actually be used throughout the system. Automatically, we'll see it will come right down with jQuery validation on the client side and give the specific error message we've defined in how many places? One place. One place in the whole application is all I have to do to define these attributes. And everywhere throughout the system, it'll make use of it. No matter how many pages have an edit control for the first name, they'll all use the same error message, right? And the same validation requirements and so on. So it's a real example of what is often referred to as the dry, don't repeat yourself principle, right? Rather than having to plug in an error message all over the place and have, you know, them go out of sync because you update one and you forget to update the other, right? Somebody doesn't like the name dummy being used in the user interface. Well, it's in one location, so I don't have to repeat it over and over again. Okay, now let's see what else we could do. Well, you know what? First name, that's a good programmer's identifier, right, for a field in a database, but that's not a very friendly label to have sticking on a screen. It looks unprofessional. We wouldn't want it to display a label saying first name with no space in between, would we? We can fix that as well with an annotation. I don't know why I usually put it on top, because it doesn't matter. The order of the annotations is immaterial. Display. And there's various things we can do in here, right? But one of them is name. Name equals. So here's where I can give a user-friendly name to use whenever it is going to generate a control to appear on a web page referring to this property. So I can just call it first with a space this time, name. Right? That's another example of doing something in the code here with an annotation that will affect the user interface. So instead of using the actual programmer's name, first name with no space, it will use a friendly display name instead. All right. So at this point, I'm going to copy paste my other ones in. Notice with the middle name, I don't have a required attribute because, you know, not everybody has a middle name, right? So first and last name are required. Middle name can be blank, right? So in the database, it will be allowed to be null. Okay, the last name here, and away we go. All right, so that would be good enough for now. Okay, so let me start my patient one as well. We'll add patient. Oh, add class, sorry. Called patient. Okay. Now, don't be overwhelmed, but I'm going to copy in all this code at once. Okay, blood everywhere on the screen, right? Don't worry. If I go to any one of them and control period, add that using for system component model data annotations, and now it's all happy again. But here's a few more interesting ones thrown in. Look at that. Regular expressions. Yay! You gotta love regular expressions. They're a way to define a pattern of characters. So you can even go down to this type of fine control you use the regular expression validation control and with web forms. Well, it's the same basic idea here. We pass the a string for the actual regular expression. So this one is just digits, 10 exactly, not 9, not 11, and nothing but a digit, right? So that will be a good OHIP number. Notice we're setting the string length to 10. Well, I don't really have to worry about the length from a user interface point of view. My regular expression takes precedence over that. That's more specific in terms of what characters can be typed into the text box. But I still want the string length there just so the database doesn't create a nvarchar max again, right? We don't want that. So the string length is really just there to define the size of the field in the database. 10 characters, that's it, no more, no less, right? Okay. Oh, by the way, in the regular expression, like if you go and look on regex.com or any of the sites out there that help you make your regular expressions, you would see this probably same one with a single backslash character at the beginning, right? The reason why we have 2 is in strings in C#, the backslash is used as an escape character, right? So we need to have 2 to say, no, we really mean, I really do want 1 backslash there. So we escape it by putting 2 in a row, right? And let's see what else we have in here for fun. Okay, that's all pretty standard stuff. Oh, here's a date of birth, right? Now, in the scenario I used to give out at the beginning of the course, but you know, we've done this medical office one, I think, together before. Most people have seen this used as a classroom example. The date of birth is usually set so it's not required. Well, that's fine in the database, right? You can just say allows null, right? Or just say no, and that's okay. But C#'s a little different because we actually have to store the data in a C# class that can talk to the database. Well, most of the built-in data types in C#, with the exception of string, don't like null values. Won't allow a null value, whether it's decimal, int, or anything like that, date, time, you're not allowed a null. It has to always have a value assigned. There is a way to get around that. You can put, with the greater than less than the angle brackets in front of the variable name, you can put the word nullable. And that then makes it a nullable type. So besides the normal things you could store in the integer or date time or whatever it is, it can now be null. But you know, that's a lot of work. Finding, you know, on the shift key and hitting those angle brackets and typing, you know, all those characters for nullable. I like nice shortcuts, and the question mark is it, right? So just put a question mark behind the variable name, and that's a shortcut to say it's now a nullable, right? We'll see later on in code that you get a couple extra properties if you make one of these data types nullable. There'll be things like dot has value, which will be true or false. It's a quick and easy way to find out whether it's null or not. Okay, and there's dot get value or default. And that converts it from a nullable type into the base type itself back again. Okay? But anyway, that question mark then allows it to be nullable, right? And of course I don't have required on here because then that would defeat the purpose of having it a nullable date time. I could talk about data type for a second. Okay? Setting the data type, even without that display format, what that would do is it would automatically then, whenever it's displayed on the screen, it would get rid of the time portion, right? You know, a date time typically has year, you know, month, day, hour, minute, second, milliseconds, right? Well, all that time information usually isn't set, and so it's just like midnight, okay, 000, whatever, right? But it clutters up the screen. So just putting data type, specifying it as .date, would take care of that, would format it as a short date string, right? However, we can go even further. Oh, and by the way, it also then sets the type attribute in HTML so that any modern browsers like Chrome and so on, okay, when you give when it's displayed, you get the little drop-down calendar, right? The little calendar control is provided by the browser itself. And that all comes from setting the data type to a data type. The reason why we have this display format is for Chrome. Chrome says it's not a bug. I call it a bug. But in Chrome, if you have data coming from the database to be displayed in a text box on the screen on an input type equals text, if you don't have the date laid out in this exact way, it won't show it, right? It's Chrome only, it's their issue. But a lot of people use Chrome. So So to accommodate it, we're setting the data format using a data format string to be year, 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 month, month, day, day. Right? And that way your data will appear in the browser in Chrome properly. If you don't put that in there, you won't see the date. Right? It'll just show the little skeleton characters of year, year, month, day, but it won't show the actual numeric values that are already stored in the database. Okay, so this one's a little interesting. It's a byte because it only has to hold a value from 1 to 12. So we have a range attribute. So I've got a range that my expected yearly visits, how often I expect to see a patient in a year. Okay, it's a stupid, stupid property, I know. But I was trying to come up with an excuse to have something on here for a patient that had a range. So it's what my brain thought of. I apologize if it's stupid, but at least it gives me some kind of small integer value that I can put a range validation requirement on, right? It has to be between 1 and 12, or you get the error message, the number of expected visits per year must be between 1 and 12, okay? All right. Oh, other interesting things. So here's an email. So I have the data type email address, right? So that means that in the user interface, it'll appear with as a hyperlink automatically. You can click on it and email to them. Same with the phone number, doing the data type phone number, right? So if they have Skype or some other phone telephony tool on their PC, they can click on it and actually have it just dial, talk through their headphone microphone they have plugged in through USB or whatever, right? Oh, you might say, why do I have the phone number as an int64 here? Truth is, I started off, I used to just use a string, right? Characters to store the phone number. But I like to format it when it's displayed with the little round brackets around the area code and the dash and everything. And you can't apply data string format to a string, only to a number, right? So I decided, well, I'll store it as a number then, right? So I can apply a nice format to it, like this one right here, okay? But in order to hold an entire 10-digit phone number, a regular size int is too small. You run out of room, right? So that's why I had to make it an int64. By the way, this display format attribute, you notice that it has a option, apply format in edit mode, right? So with the date time, I said yes. So it would keep the same format even when you're editing. But with the phone number, I say no, or set it to false. Because I'm expecting you to enter, as it says up here, the 10-digit phone number with no spaces. So just type the digits, right? It's easier to validate that with a regular expression, only because I'm too lazy to figure out the proper regular expression to do it with the brackets. Yes, you'll get to know me. I'm quite lazy. Okay, there you go. But it works. People often are quite used to that. You type the number without any extra spaces or characters, and then once you've finished entering it, it'll appear nicely formatted for you. So there's a few extra ones in here. Now, let's get down to the fact that these two separate classes relate to each other, right? Doctor has many patients, so it's a one-to-many relationship. And a patient has one primary care physician, right? How is that defined? This is all it takes. By putting in the child object, a virtual doctor object. Virtual just means it's overridable, right? You're familiar with the term override? Okay, so override a virtual property that makes it possible. So we're just storing the doctor as an object of the primary care physician for the patient. And that's all it takes in our model classes here so that Entity Framework will know to create a foreign key relationship. Only problem is it will create an integer, okay? An integer ID foreign key to correspond to the primary key integer of the doctor, just as you would normally in a SQL Server database, right? When you take the primary key of the parent, cast it as the foreign key value in the child. Well, it's going to do that, but it'll give it its own ugly looking name. So what we normally, and it's just used internally by the system, you have no access to it. So what we normally do, along with the fact that we have the doctor object, is we make our own integer. It gives me two things. That way I can specify the name of the foreign key integer value, and that's what I usually do, is I'll take the name of the parent class and stick ID on the end. And that's the good name for the foreign key, right? So inside the patient table, we'll have a doctor ID column that stores the ID where it's the primary key of the doctor. So if it's Dr. 527, right, is Joe Smith, right, his ID is 527, then all his patients will have 527 stored as the doctor ID property of the patient themselves, the patients themselves, right? So it's true it would make the relationship without this, but then I lose track of it. I don't have a way to access that property in code. And believe me, it's much easier to just access the doctor ID, the integer value. Otherwise, you have to always instantiate a doctor object and work with it instead, right? So for programming, it's much better to have the best of both worlds. We have both the integer foreign key value, and optionally, we can populate it with the actual doctor object if we want. All right. So to go along with that, that's all it really needs on the client side, or the child side, I should say. But going back to the parent, the doctor object, how does it know what patients he has? Well, we could always run a query with like a join between them, and we could find out, right? But wouldn't it be nice, okay, cue my Beach Boys song, wouldn't it be nice if when we instantiate a doctor, he could also go and get all of his patients and bring them along on the same trip to the database? Wouldn't it be nice? That way, we only do one query to the database and we get all the information about the patients with the doctor. We call that eager loading, right? You may have talked about that in the past, the difference between lazy loading and eager loading. If I was going to lazy load, okay, I would go get the doctor, and then if I want to produce a page showing the name of the doctor and underneath a list of all their patients, then I'd have to do multiple queries to go back and get each patient one at a time, right, and hit the database over and over and over again. Whereas if I do an eager loading situation, I go get it all at once and don't have to hit the database over and over, and I get all the data. In order to accommodate that, what I'm going to do inside my doctor, I'm going to add a property. I really am once I get my insertion point set in my text file. So inside the doctor, we will add a collection of patients. Okay? It's virtual, so we can override it. Any framework can take control, populate it with a collection of all the related patients. Right? We'll see in our link queries later on, we can do that just with a called a dot include. So when I go get a doctor, I can go dot include patients. And it'll automatically load all the patients relating to the doctor into the actual doctor object itself. So it's now self-contained. It has all that data inside the object because it's got a spot now to hold that entire collection of patients. Right? The last thing I'm going to do in terms of modifying this is there can be, it's rare, but there can be circumstances if somebody goes to, because now this is a property, right? So they could go the doctor dot patients, and if it hasn't been instantiated at all, you'll get a null reference exception. I don't want that, okay? So what I can do is in the constructor, you know how to make a constructor, right? I usually, well, it doesn't matter. I'll put it at the top. Okay, this is public class doctor, so if I just say public doctor, right? And then a couple round brackets, then that is the constructor. Of course, you can overload. You can have multiple constructors with different signatures, different parameters you might pass in, right? That's polymorphism in your object-oriented course. But we just need one constructor here. What I'm going to do is I'm going to say this dot patients. That's my property that contains the collection of all my patients, equal to a new, well, I could say list of patient. That would be fine. But the most lightweight thing I could create is a hash set. No, this has nothing to do with the new program that just started up in Niagara-on-the-Lake. Okay? It's a new hash set, not hash, of patient. It's just a bit of a safety mechanism. Just to prevent if somebody tried, if I instantiate a doctor object and I don't include any patients, if they try to access the patient's collection, I'll get a null reference exception. But but now I won't. Because when I build my doctor object in the constructor for it, it'll automatically initialize it to an empty collection. It'll be empty, and it's the most lightweight collection there is as a hash set, right, of the particular type of object. And that's it. I'm done my models. Okay, so I have my two models in place, my doctor and my patient, so I'll just save. All right. How much time do we have left? Not very much. Okay. Well, why not barrel ahead? We'll see as far as we can get. I see you again tomorrow, right? So we'll just pick up wherever we leave off, but I have time to go a little bit further. So the next thing we would usually do, back with the .NET framework, is I would go and create my own DbContext, right? I'd use my own DbContext to look after my production tables, my doctor and patient tables. I can do it here too, but the trouble is, instead of being one simple file, because of dependency injection, I have to modify 3 files in total. So it gets a little bit hairy and messy. The code is kind of ugly, and there is a little wizard that does the work for us. Do we like wizards that do the work for us? I do. At least as long as I understand what it's doing and I can fix it afterwards if it messes it up, right? The only problem with this wizard is that in order to get it to run, it actually has to make a bunch of stuff the wrong way that I'll delete it and make it again later. Okay, so 6 of one, half dozen the other, but it's probably the easiest thing to do at this stage. And it follows the same approach that you're going to do in that tutorial. So what I'm going to do is I'm going to jump right in and say I'm going to make a controller. I'm going to right-click controllers, add, look at that, it's right at the top, controller. I could go new item and find it in the list, but it's right there. Pardon me. Okay, this is the one I want. An MVC controller, not an API, with views using Entity Framework, right? I click Add. Now in this dialog box, see, we already have that one application DbContext that was there for the security system, but I want to make my own. It's not here yet. So here is where I can click the plus sign. So it's going to make the data context for me, and it will fix it up. It'll add it to the services available for dependency injection, create a connection string and everything else for me, right? That's why this little wizard is a time saver. The only thing is, I'm a die-hard person for a certain approach in life. This isn't the end of the world, I confess. This is more my personal preference. But you see, it's going to create it in the models namespace, right? This is my project name, .models, which is, it's going to put it in the models folder, right? And to me, that's just wrong, right? This is not a model, right? This is a context object. It should be in the data folder. So I like to change it right now. I'm going to change models to data. We can do that. We can take control and say, no, I want it over here. I think it fits better in the organization of the overall project as under the data folder, because it's really not a model. It's not part of our data domain, right? Medical office core context. I'm going to shorten that up to just medical office context. Okay? And that's just the name for it. So I'll click Add, and there we go. So that's my new context. Now, truth is, it hasn't actually done any work yet. Not until I get out of this dialog box and click Add does anything actually happen. So I have to go through the process. Okay? So I'll pick doctor or patient, doesn't matter which. Notice we have some checkboxes over here. It's going to generate views. I guess I could take that off because I don't really want to. Oh, well, I'll leave it on for now. Reference script libraries, use a layout page and so on. We'll talk more about layout pages tomorrow. But it's going to create a controller called Doctors Controller. That makes sense, right? When you have a bunch of doctors, individual doctors, you say it in a plural, right? It makes sense. It's plural. A collection should be plural. I'm driving that point home because it bugs me that the .NET Core doesn't know that yet. It's stupid. Okay? So I'll click Add. I'll let it build all this stuff just so it can make my context and get all the plumbing in place and dependency injection services and so on. Okay. But the problem is, so here inside under data, here's my new context object. Yay! It put it where I wanted it to be, right? See, that's where the application DbContext is, right? It makes sense that my DbContext should be in here too. Okay. But look at this, okay? It's called this whole collection. A DB set is just a fancy, I can take out this fully qualified because using is up top, right? A DB set is basically Entity Framework's collection. It has all the smarts built in for inserting, updating, and deleting, right? That's why it's a DB set. It's not just a collection. It's part of Entity Framework. So inside my DbContext, my way to talk to and connect to the database, here's just the constructor, right? And then here is my DB set for doctors. So this was all created by that little wizard. Why doesn't it have an S? I just can't let it go. I mean, it just, to me, it's wrong. It's a sin, right? Collections should be in plural. So I'm going to manually change it. There we go. I'll save that. And now I've broken all the code that was scaffolded inside the doctor's controller and all the views, because they expect to see a collection with the name doctor, right? But don't worry. It's easy. All I do is I come over here to controllers. There's my doctor's controller. Delete, delete. Yes. Come down to views. Okay, here's all the doctor views. There's 5 of them: index, edit, details, delete, create. I'll just select the doctors folder. Delete. I'll just recreate it now that I fixed the DB set, right? So I'll come back up here to controllers, right click. Only takes a jiffy. Yeah, MVC5 with all the goodies, thank you. Now it has my new context objects. That was made correctly, and I fixed the name. And so I'll select doctor again, doctor's controller, regenerate the views, add. Thank you. And now it's fixed, and I can use my plural name for my collection of doctors. Yay, I know. I could have put up with the stupid naming convention of calling a collection of sticks. Well, no, that doesn't work very well. Poor example. Collection of book called book. You know, that makes no sense. You got a stack of books. I'm not going to call that a book, right? Anyway, you get my point. So now it's happy and I'm happy, right? So here's our here's our controller, right? And away we go. And all the views have been recreated again. So that's good, right? So we fixed up the context class. Now I can manually just add my patients as well, right? I can do that with prop, tab. It's a DB set of patient objects called okay. See what I mean about my typing? Patients. There we go. So now I'm set. I have DB sets for both of my model objects, my doctor and my patients. So Entity Framework through my DbContext will be able to insert, update, and delete all my doctors, and away I go, right? Just before I finish inside here, though, something I used to always do. You remember cascade delete, right? Cascade delete, what that means is in a parent-child relationship or one-to-many, if you delete a parent object, all the related children get massacred as well, right? Horrible, horrible picture, right? It should not be that way. By default, usually you want to protect so that the parent record can't be deleted if they're related child records, right? So in other words, in our case, you know, I shouldn't be able to delete a doctor if there are patients assigned. I should have to reassign them all to a different doctor first. Once that doctor's got no more patients assigned, then I could delete the doctor, right? That's how it should work in this case. It used to be with .NET Framework, I could in this, there's an override for the OnModelCreating event here in this class, where I could say, change that convention. By default, all one-to-many should be cascade delete off, right? Unfortunately, that doesn't exist yet in .NET Core. So we'll have to use a little bit of extra code just to make sure that my doctors are protected from being deleted if they have any patients. So the code for that, it's in my copy-paste file. Maybe I'll put it all in and we'll talk about it. Sometimes that's the easiest and least painful thing to do. So we're going to override is an event called OnModelCreating, where we can take control of how the model is built, right? Okay. So with this override then, basically, the first thing I'm doing here is I'm giving it a default schema. So all the tables will have the same schema through this DbContext. You remember schemas in SQL Server? Yeah. By default, what was the schema that everything would get? 3 letters? DBO, exactly, right? Database owner is what it stood for. So if you don't specify otherwise, that'll be the schema of any object you create. But you can create a schema. It allows you to organize a large, complex database then, right? So you might have all the tables and so on related to inventory and an inventory schema and HR schema used for all the human resources tables, things like that. So if you have hundreds and hundreds of tables, you can have them more organized. Well, I like to put a schema to a DbContext because I'm cheap. If you're eventually going to host this up on a service like Azure or even Amazon, right, you pay for every database, okay? It's more expensive to have 2 databases than 1 big database. So it's a way that I can put all the tables for this application under one schema. That way if I have a doctor table here, or let's say something more generic, an employee table, right, in one application, and want to reuse the same database with a different application, but it also has an employee table, well, they would conflict unless they're in different namespaces or schemas, right? Schemas like a namespace is what I meant to say. So by creating a schema, it means I can reuse the same database for a whole bunch of different applications and the tables won't bump into each other. They can have the same names and it won't be a problem. That's the reason why I have this line. Simple as that, and just gives a schema to all the tables. Okay, this is the one for cascade delete, right? I have to go through all this code. This is, by the way, called the Fluent API. I think that's an oxymoron. There's nothing fluent about it. But the developers of .NET, that's what they called it when they first came up with this approach. Okay, so basically what it's saying is, hey, model builder, when it comes to this entity called doctor, right, there's a few properties I want to make sure are perfectly clear. Okay? Now, everything up to here is already looked after. We wouldn't need this because of the naming conventions, right, that we've used and how we set up the model classes. Just the annotations that are there and how we set up that virtual doctor inside the patient. All of this would be taken care of. I don't need this code except for the last line. But I can't give this line without all the rest, right? So I have to basically repeat myself saying, well, a doctor has many patients, right? And with one doctor. So the patient has one doctor, right? So it's just redefining the one-to-many relationship that it would have understood even without this, right? Has foreign key, that's the doctor ID that I created, right? I have to go through all that though just to say, hey, the on-delete policy is restrict, right? In other words, that we're going to be restricted from deleting if there's related child records, right? So all that is just to get the cascade delete turned off in this relationship. But while I'm here, this is a good place because, again, in .NET Framework, I can just put a little attribute on a field to say index. In brackets, is unique, yes, true, right? That doesn't exist in .NET Core yet, but I can accomplish it here with the Fluent API. So I'm saying, hey, Mr. Model Builder, when it comes to that entity called patient, okay, I want it to have an index on OHIP that is unique. Because it makes sense. No 2 patients can have the same OHIP number, right? That's just a rule in the real world. Right? So we should enforce that in the database as well. Okay? So that's the way to do that because we can't use just an annotation with .NET Core, but we can still use the Fluent API. So these are all the changes I need to make here for my actual DbContext object. A lot of information I know in one day, first day here. Right? We have 2 minutes left. I don't have time to, well, if I try to run it without doing migrations, it'll give me an error because I don't have a database. So let me just quickly, that's a shortcut. You can use the quick launch to find things that are way down in the menu system. So here's our package manager console. Okay, rather than explaining these commands, I'm just going to give them. So basically, I'm saying we're going to add a migration. Okay. Now I have two different context objects: the application DbContext, that security one that was there already, and the one I just added, right? So which one? There'd be confusion. I get an error message saying, "Oh, you have multiple context objects. Which one do you want to migrate?" Right? So I have to say, well, the context is my medical office context. The -O is just for an output directory. It would by default create a new folder called migrations right in the root of the solution. Not what I want. I want it underneath data, but there's already one there called migrations, so I have to change the name. So I called it MO migrations, right? And the last part is the name of the migration. I can leave that off, by the way. If I press enter, it comes down here and says, oh, wait a second, you have to supply a value for the name, right? See, I can't mess up. It's a good thing, because I tend to mess up so much. Initial, did I spell that right? I don't care. Okay, and there we go. And off it does. It created a migration. Just to quickly look, you can see it over here. It made our folder, made the migration. Migrations have an up and a down, because what goes up must come down. Well, actually, it's because we can apply migrations in series. Every time we make a change to the model, we just add a new migration, and it will apply those changes to the database. Oh, I left out a property. I'll just add it, add a migration, update the database, right? So all the code in the up is what gets executed when you apply the migration, right? So here we'll see create table with certain properties, so on and so forth. Now this isn't SQL yet. This is still C#, but describing how we're going to create the different database objects, right? Including, you know, indexes and so on and so forth. The down, if we roll back this migration, basically just drop the tables, right? And that's it, okay? So last thing is to update the database. I'll come down here to the Package Manager console. I'll bring up that same line, but the up arrow brings your last commands. I'll change it to update database. And I could leave that there. It doesn't hurt, but I don't need it anymore. You only need it when you first create it, that output directory specification. And there it goes. It's going off, creating the database itself. Takes it a moment or two. And if you look carefully, you'll see create table statements and so on in here. So it actually worked. I will let you go in 2 seconds. I just want to show you it working. So if I just go / doctor, for example, doctors. Right? Here's my doctor's controller of the index. Let me accept the cookie. I click create new. Notice if I click create, there's my validation error messages from my don't repeat yourself, my annotations. Right? Type anything in here, click create, and there's the doctor. I can edit the doctor, right? Go back to the list, do the details, back to the list, delete. The scaffolding is all in place. Bada bing! Okay, we'll continue tomorrow.